Hi. Today the main topic is what is a bus? It's just a recap of the explanation. Because I took two videos of explaining bus, so today will be the last video of talking about this kind of topic. So what is a bus? Bus is just a groups of wire. It's just group of wires that inside of your computer that connects to the CPU and the memory. That's simple, right? But the thing is that there's a purpose of these wires. And the bus can divide into three buses, which are the first thing is address bus, and second thing is the data bus, and third control bus. And these are the types of the bus. But I think we should ask ourselves, why do we need some kind of this kind of bus? Why we made the purpose of the bus, and what is the address bus? Why we need such as address bus, and why we need some kind of control bus? Why we need some kind of data bus? Why don't we just send all of the bunch of data and bundles it and just send it to the some kind of CPU or the memory? That would be simple, right? But the thing is that if you look at it, how does it works inside your computer, especially the CPU and in your memory part, you should be able to understand the purpose of this bus. This is really really simplified diagram of x86 architecture. There's a memory interface and there's a BIU EU. The BIU is bus interface unit and EU is execution unit. And of course, inside your CPU, there are special profile of the register, and there are general purpose of the register, and there is a special profile of the register, and inside these registers, especially host second register and instruction pointer register, we utilize this kind of register value to fetch the instructions. And why we need some kind of fetch thing? Why we need some kind of instruction? Why we need to get some kind of instruction? You know, the instruction means that it's just a command. CPU has to get the order, and we are the one who commands it, and we have to specify the instructions, and these are the instructions, and the instruction is represented as the normally assembly instructions, and there are like move and pop and push and those kind of stuff. And we're not gonna elaborate some kind of instruction because there are lots of it, but today I'm just gonna talk about there are instructions and we need to store into memory. But why? Because there are lots of instruction we can write, but the CPU has to do the one instruction by time and time. It cannot do it concurrently. It cannot do two commands in the same time. It has to do one command in the one time. And that is why we just store the instructions, our bundle, and we just store into memory. And that's really simple, right? But the thing is that we just store it and we have to get it. We have to get the next instructions, and that's called a fetch. Inside CPU, there are three actions, which is fetch and decode and execution. Yeah, execute, whatever. And inside BIU, we do the fetch action, and inside EU, we do the decode and the execute action. But let's try to elaborate the fetch action more. The fetch action is basically we want to get some kind of memory address because we want to find our instruction. For example, we have 4 instructions here. Here 1, 2, 3, 4, and of course we want to run this instruction in the first time. We have to run this instruction first, and And second, we have to run this instruction second time, and by time, line by line. And the thing is that we have to store it, and we have to get this memory address value, and so that we can just send it and give a request of using this data bus, not address bus. So address bus, it's just a highway. We can drive in the highway, right? And in this computer architecture, the highway is called the address bus. I mean, inside the address bus. I'm talking about the address bus, not the data bus and control bus. We are in the highway, which is address bus, and the car and the content inside the car is just our address value of the memory. After that, we were able to get the data of it. So what kind of data? The instruction data. We get it from the data bus. Of course, the highway is the data bus, and the car is the data. We're just sending the data using this bus, and we send it, and of course we have to give the signals of it. It's called control signals. Control signal is just the signal that you want to do with this memory. We can read the memory, we can write the memory, or we can do input and output, or those kind of stuff. And basically, the control is this control bus is just a highway, but the car is just signals. Read, if it is read, they're gonna read it. If it is write, it's just gonna write. But the thing is that the control signal is kind of not normalized. It's just different. It's just different. If you're in the x88 8088 architecture, but if you look at the 8086 architecture, there will be some difference because because this control signal is basically based on the CPU pin of it. If there's CPU and there's a pin of it, and there's kind of something read or write and those kind of stuff, there's control signal, and that can be different based on the processor's specification. But the thing is that, but normally there are read and write. So basically we just send the signals that we want to read, and we can read it, and of course we have to get the data of it. We have to send the address value on it, and that's the fetch process. And in this fetch process, these are the bus. Don't think about the bus just like the car, not just the square bus, those kind of things. It's just a group of wires, but there's a three purpose of it: for the address, for the data, and for the control signals. It's just simple. And after that, after you get the data, you have to put into this prefetch queue. It's just a queue, FIFO, first in first out. It's just a data structure with just some kind of array. And of course the first value will be the first instructions 0, and you're just gonna enqueue and the dequeue of this queue, and the inside you will decode this kind of instruction and you will execute after decode. So that's kind of process of it. And also you have to increment the program counter based on the size of your instructions. Let's say 1, so we're just gonna go to here. And for that, we just enqueue on the queue, prefetch queue, and after that, EU will be doing the decode and execute while the BIU doing the fetch process. It's just doing concurrently. So let's summarize. There's a bus. Bus is just a group of wires inside between the processor and memory, and there are 3 purposes of it. One is for the address, and one is for the data, and other one is control signals. And basically we are using that to communicate with the memory, and the reason why it is important because based on this kind of bus, we can predict the data or address or control. We can just split our interest on it. We just wanna care about order. We just wanna care about data. We just wanna care about control signals. And based on that, we can do the fetch. After fetch, we just gonna push our in queue our instruction to prefetch queue. After receiving a prefetch queue, this execution unit, we're gonna dequeue the first one, and we're just gonna decode. Inside here, there's a decode and the execute. And after the decode and the CPU gonna do the execution, right? And that is how it goes. Pretty simple, right? And that's it. And next video, I'm just gonna try to talk about the decode thing, because I didn't talk about how deep is decode and how does decode works, right? I'll just talk about the fetch thing. So next video, I'm just gonna talk about the decode and the execute thing, and also prefetch queue. I think I have to implement more about this kind of thing, and control system and how this works. And A bus, what I know with A bus is just address bus, and B bus is data bus, and those kind of things. Yeah. So this is it. Have a nice time and see you next time. Have a nice day and see you next time. Goodbye.